Hey guys, here is your Unit 1 test review for 7th grade. So I'm going to take a look at number 1 here. It says the tree diagram represents the relationship between the sets and subsets of rational numbers. What kind of numbers could be placed in section B? So I'm going to jump over here. So right here we see 0, 1, 2, 3, so these are whole numbers. Up here we got our rational numbers, which means that these are integers. I'm just going to shorten that because I'm running out of room already. Integers are just like wholes, but they are, so we've got integers, oops, let me write that real quick. Integers are just like whole numbers, but what we're going to do is we're going to include the negatives as well. So just about any number could go through here. So we've got -3, -2, -1, 0, oh, that's supposed to be a comma, 1, 2, 3, more commas. So this can go on. So pretty much any positive or negative whole number. Now take a look at number 2. So number 2 says, in January the temperature was 9 degrees Fahrenheit. The temperature dropped 12 degrees. What is the new temperature outside? What I want you to realize right off the bat is if we are going to drop 12 degrees, this is the same thing as subtraction. So what we have here is 9 minus 12. If you can't see that we're going to have a negative for sure. You can keep change opposite if you want and then follow your rules, but I know that I can subtract these two and that I'm going to have a negative as my final answer. So I'm just going to kind of count up from 9. So 9, 10, 11, 12, that's 3. So our answer is going to be -3 degrees, and you can put the Fahrenheit there if you want to get really picky on it. Now for number 3. It says, draw a visual representation that correctly describes the relationship between sets and subsets of rational numbers. Include rational, whole, integer, irrational, and real. I'm going to zoom way in on this one. Pretty much it's just the setup that we always do. We've got our big old thing of real numbers, so I'm going to write real in here. Off to the side over here, we're going to have our irrationals. So I'll change colors for that. Write this real quick. Irrational. Don't feel like writing all that out. And makes this side rational. So now I'm going to draw my circle. So the next circle in from rational would be integers. This would be whole. And then this would be natural. So now I'm just going to kind of go through and label it real quick. So there are my natural numbers, my whole numbers, and my integers, rational, and then real. Hopefully yours look a little bit prettier than mine. Now take a look at number 4. Hopefully this sounds familiar because we've been over this one before. It says Jessica went to the grocery store and purchased a box of cereal for $3.75, milk for $1.50, and bread for $2.25. She paid with a $20 bill. How much did Jessica receive? Or how much change did Jessica receive? Just like going to the grocery store, we got to get a total first. So we bought the cereal, we bought the milk, and we bought the bread. We need to find out how much our total is first. So off to the side real quick, I'm going to add these up. I'm going to kind of zoom in here real quick. So we've got $3.75, $1.50, and I already forgot what that other one was, $2.25. And just to save some time, I'm going to go ahead and write $7.50. So that was our total for the bill. So here's what we do now. We know that that we're going to pay with $20 bill. We're going to pay with $20 bill. So now I'm going to subtract that $7.50 because I want to know how much change we're going to get back on this one. And when you run through that, you find out that you are going to get $12.50 in change. That's supposed to be a dollar sign. I know that came out terrible. All right, number 5. Nicholas has 5½ cups of flour. The recipe for a cake he is making calls for 3 3/4 cups of flour. He also needs 8 cups of flour for a cookie recipe. How much more flour will Nicholas need to make the cake and cookies? Understanding what's going on here is extremely important. This 5½ is what he has. The 3 3/4 and the 8 cups are what he needs. So we're going to put these things together first, and I'm going to go ahead and cheat on this, guys. We're going to make this decimals first. So we've got 8 cups that he needs. I'm going to put my decimals on there. We also know he needs 3 3/4. Well, you can just do top in, bottom out, or divide it, but 3/4, most of you guys know that this is going to be 75 cents. So we just add these two together real quick. We get $11.75. So he needs 11 3/4 cups of flour for this. So he's got 5.5. We need to find the difference here to figure out how much more he needs. So 1175 is what we need, and that 5.5 is what he's got. I'm going to go ahead and change this to 5.50 and just subtract from there. So working through this real quick. So we get 6.25. 6.25 is not wrong, but you'll need this as a fraction for your multiple choice test. So it's going to be 6 1/4 cups of flour. Now to move on. Number 6, Cole is making decorated jelly bean bags for a party. Each bag contains 5 pounds of jelly beans. If Cole has purchased 1,000 pounds of jelly beans, how many party bags can Cole make? So things to keep in mind that Cole, for one, has a whole heck of a lot of jelly beans, but we're going to be dividing this up into smaller bags. So we're going to take that 1,000 pounds, and we're going to divide that into bags that are 5/6 pounds. I'm going to put this over 1 right here, and then I know from there I can do my keep, change, flip. You guys just love keep, change, flip for some reason. So I'm going to keep the very first one, my 1,000 over 1. I'm going to change the sign to multiplication, and I'm going to change this to 6/5. Guys, this is only for division. Can't stress that enough. So now 1,000 times 6 is 6,000. And then 1 times 5 is 5. So now I do 6,000 divided by 5. And you can do that off to the side if you need to, but on this one it comes out to 1,200. So you can make 1,200 bags for his 1,200 Facebook friends, I guess. All right, just a few more. This one's pretty tough. To complete a planter box project, Mr. Michaels will purchase cedar boards that are 2 inches wide and 8 feet long. He will need to cut down the length of the boards into pieces that are 1 1/3 inches long. How many pieces can Mr. Michaels cut from each 8-foot long board so he can determine how many he will need to purchase? When in doubt, draw it out, which rhymes, but I had no intention of making it rhyme. So this board right here, this thing is 8 feet long. He's about to make this into much, much smaller pieces. So he's going to do like, was it 2 1/3 inches? No, I'm sorry. I can't see from where I'm at on my screen. Sorry, 1 1/3 inches. So he's going to be cutting that 8 feet up into itty bitty parts. So what I want you guys to keep in mind is as we're cutting this thing up, we are getting more and more pieces. Also, that 8 feet long, it's difficult to understand how much we're going to need unless we convert that feet to inches. So 8 feet times 12 will tell me that I'm going to need 96 inches. The width of the board in this case does not matter. We do not need it. So I'm going to take my 96 inches and I'm going to divide it into 1 1/3 inch pieces. You could probably round this to 1.3 repeating, or just 1.3 if you want to do decimal form. But for now, I'm going to keep it just like it is. First, I need to make this an improper fraction. So I do 3 times 1 plus 1. So I end up getting 4/3 here. So that's the fraction that I'm going to use for that. So I'm going to keep my 96. I'm going to call it 96/1. I'm going to change my sign to multiplication. And then I'm going to do 3/4 because I have to flip that final one. Now I just multiply straight across to the bottom because it's easy. 1 times 4 is 4. And 96 times 3 is going to be 288. It's really lousy looking. Let's see if I can fix that. So that's not a wrong answer, but we need to simplify this. So I'm going to do top in, bottom out. I'm going to see how many times I can go into 288. So I know that 4 can go into 28 7 times. Nothing left over. Got my 8 there, and then it can go in there 2 times. So we can make 72 pieces out of that board. Number 8. Gracie is selling picture frames and wants to compute the areas of each of the frames that she sells. One of the frames measures 1/2 foot wide and 3.8 feet long. What is the area of this size picture frame? So to find area, we're just going to do length times width. So we're really just multiplying these two numbers. So 1/2 times 3.8. I really think the easiest way to do this is just going to be 3.8 times 0.5. And just multiply that out. So 5 times 8 is 40. 5 times 8 is 15. Plus 4 more is 19. And then I've got 2 decimal places. So the area is going to be 1.9. What are we talking about? Feet here? Yep, 1.9 feet squared. And finally getting close to the end, 2 left. So Fidel has $217.18 in his checking account until the end of the month. Fidel writes a check for $357.42. How much does Fidel have in his checking account, or now have in his checking account? So we're taking this $217.18, and he's writing a check for $357, so that's going to be taken away from his account. We are clearly looking at this, we're going to be getting a negative number. So just subtract it like normal. You can do the 357.42, you can subtract the 217.18, and we know that it's going to stay negative, so that'll be 140.24. I know I'm kind of cheating because I'm using a calculator here, but I need to wrap up this video because it's taking too long. Alright, finally number 10. So Savannah discovered an error in her checkbook register and recalculated her balance. She determined that she was overdrawn. Her balance in her checking account was negative $638.57. Savannah has saved 2 of her paychecks. That's important. Each in the amount of $298.40 for a special occasion. If Savannah deposits both checks in her checking account, what would be Savannah's new balance? For starters, let's figure out how much she's actually going to be depositing. This $298 right here, she has 2 of these checks. So we need to find a total. So I'm going to cheat here a little bit. I'm going to do this in the calculator real quick. I know that she's got a total of $596.80. So $596.80. Well, she's overdrawn $638. Even if she deposits this $596, she's still going to be short. Okay, so we know our final answer is still going to be negative. So I'm going to write this over here off to the side. I know it's going to be negative. So I'm going to take the $638.57, and I need to find out the difference between these two. So I'm going to take, that's supposed to be 96.80. We're going to be subtracting these two. And again, I'm going to kind of cheat just to fill up or quit wasting so much time. We get 41.77, and again, this ends up being negative because we knew she didn't deposit enough. So that's going to be a negative 41.77. So that's how much money she still owes even after depositing.